Yeah, hello students. You are welcome to another wonderful video of mine. And today we are looking into vectors as part of the request video from some of our students. And here we are going to have 8 different sections on all what is needed to be known for GPEB, on vectors analysis, representation, pictorially and mathematically. We are going to discuss on triangular law of vector. We're going to talk about components of vector. We're going to talk about parallelogram law of vector additions and subtraction. We're going to talk about derivation of formula and some work example. Then we go to what we call unit vector. That is the coordinate system of vector. We talk about scalar product and the vector product. We talk about IJK vector and the representation as well. And we'll take some questions from the past year questions for JUPEB and IGMB to actually see where we are. So I believe to understand this topic very well, I will always advise you that after each of the section, you prepare a question with respect to what you've learned, then you send it to us on the group or at the mail at gmail.com to actually help you to solve 1 or 2 questions. Each of these components or checklist, I call it, are based on your syllabus, and I'll be taking it from the scratch. So let's start with today's work. Now, about basis of vector. In your early classes, you might have studied what we call vectors. Now, when we talk about representation of physical quantities, there are 2. In physics, we talk about physical quantities are subdivided into, you know very well, scalar and vector. Basically, in A-level class, there's another type of physical quantity we call tensors, which is not required in your syllabus for this year. So, and because of that, I am not going to be talking about tensors. Now, about scalar and vector quantities. In early classes, we say scalar quantities are those quantities or physical quantities that has or possess magnitude only. I believe you still remember that, magnitude only. A very good example we use in early classes are what I call the work, the speed, we have the time, and the energy. So keep that in mind. These are very, very important, especially in your physics understanding. W, V, T, E. So under vector quantities, everybody knows definition. We say they are such that has the magnitudes and also the directions. So in this slide, we are going to focus only on vectors. Representation of vector in terms of its magnitudes and its direction. Now, talking about vector representation in terms of its magnitude. When we talk about magnitude of vectors, now there are 2 particular ways. A very quick one, as you know in our video, what is being taught from 1 hour, 2 hours in classes, we use 25 minutes. Now here we want to talk about the representation, a quick one. Now talking about representation of vector. Now we represent vector in physics in 2 ways. Representations, as you can see, there are 2 methods we use. We use vector can be represented pictorially, pictorial. That is by using a picture. And they can also be represented mathematically, mathematically. So here in this slide, we are only considering how vectors are going to be represented pictorially, and as well how they are going to be represented mathematically. So let's see. Now the first one, I am going to consider representation of vector pictorially. When we say pictorially, let us understand how we talk about it. We say vectors are always in magnitudes and they are also in direction. Now a quick one about this, my dear student. Let us look at the XY plane. Yeah, quickly visualize this. I hope students can see what I'm trying to bring out. Absolutely very good. Now here we have the XY coordinate system. I am explaining how to represent vector pictorially. Now we have this. We are talking about representation using arrows. When we talk about pictorial representation of vector. So when we use arrows to represent vectors, arrows, that is what we call pictorial representation. Now, as you can see in this XY plane, this is the Y-axis. Everybody should know that. And this is the X-axis. Now, here, when we try to talk about the position of vector and its angle, The vector here, let's say the vector we are talking about, we are representing it with this arrow, as you can see. Let's say we are talking about vector of A vector, you can see arrow is always on top and it's moving at an angle of 30 degrees. So this type of representation you have seen is called pictorial representation of vector. So here we say vector A is having a magnitude, a vector is having a magnitude of A and a direction of what? 30 degrees. That is the way we represent vector pictorial. So using arrows, we say vectors are represented pictorially. Now, again, dear students, talking about the mathematical form of represented vector. Now, the way we represent vector mathematically is by saying, let's take the same vector as we have illustrated here. We take vector A. As we said, vector has magnitude and direction. We say its magnitude is written as A without any arrow on top, and its direction is written as in this one, as you can see, something like a less than sign. I'll put the direction angle in form of theta. So what I've done here, the mathematical representation of this means vector has been represented in magnitude of A and in direction of theta. I hope you understand this, and that is what I want you guys to put in mind. So always keep that in mind. When you see vector in this plane, in this format, it means vectors is represented pictorially. And when vectors are in this format, it means vector is represented mathematically. So that is what we want to talk about in this slide. And quickly, before we move to the next slide, where we are going to focus more about position vector. In position vector, let's look at what we want to discuss on here under position vector. Now, position vector. About position vector, let me manage this slide for understanding's sake. Position vector. So like I said, we say vectors as those that has a magnitude and direction. In quicker one, I said they can be represented pictorially and as well mathematically. Now, talking about the pictorial, I said by arrows, and in terms of mathematics, magnitude are without arrows on top, direction is the angle in which vector is being represented. Now, the same way I've done the mathematical representation and pictorial equation, I'm going to bring down an XY plane as well for you to visualize well and understand the concept of what we call position vector. Now, let's say we have the XY plane, as you can see here, and under the XY plane, we have, let's say, for example, okay, let's wait in this form for understanding's sake. When we say position vector, we mean vector with respect to, this WRT means with respect to a particular or with respect to a reference point. Let me use that. I think that is very important. To a reference point. So because of definition, some of you might be asked to define position vector. Vector with respect to the reference point. And that is why I'm taking XY plane as my point of the reference. This is Y-axis and this is X-axis. Now, generally in physics, we represent position vector by the symbol R. You can also keep that in mind, but it is not necessary because this is also part of your mathematics for some students that are doing hard maths or further maths or whatever type of maths you call it. So keep it in mind. Either you use you can also use any alphabet. Any vector that is represented with respect to what the reference point, and the reference point is always my point of origin. Let's keep that in mind. And you can see in the XY plane, we can just take a very good example of this illustration. Let's take using a broken arrow to understand the concept very well. Now, this is my reference point, my starting point. Now, I'm having the first vector, as you can see, doing this now. Now, I'm going to call that one, the position vector of this one, I'm going to call it P vector. So let's call this one, my dear student, P vector. From the what? From the position, from the origin. This is the position origin. So we say the vector of P now, the position vector of P is represented by what? R P vector. So keep that in mind. That is the position of P with respect to the what? The origin, which is the what? Reference point. Keep that in mind. That's the first one. Now, we are talking about RP, P vector, and we say vector is always going to have magnitude and direction. Its magnitude is moving along this plane. Its direction is always towards the positive axis. Students should always keep that at the part of their mind, at the back of their mind. So P vector is moving at a magnitude of P, but at a direction of what, which we are going to call what? Theta. Let's do that as theta, because we said vector are going to have magnitude as well as direction. That is the definition of vector. Now, also, we can also take another vector from the same origin. I want you guys to just understand all this stuff. They are not difficult to understand. Let's say this one is also starting from this origin and it's moving like this. Let's call that vector Q. For understanding sake, we are going to call that vector Q. Now, the vector is now moving towards also the positive axis. Let's take the direction of that vector, as you can see, my dear student, as what? Alpha. So that means it has a magnitude of Q. It has the direction of alpha. So the position of vector of Q is written as a RQ vector. I hope students are following this. This is RQ vector. Now, to now calculate the what? The overall what? We can actually bring another vector that is like a resultant vector to what? P and Q. We are still coming to that for understanding sake. Now, we can bring the what? The third vector, which we call what? RQP. That is the position vector from point Q to point P. Now, you can see, in this case now, I am looking at a particular what? Vector that is starting what? From Q to P. So, joining the line like this, you can see, let's also use the same line to have something like triangle, as you can see. My dear students, yes, very good. Now, this particular vector, you can see, is having what? You can see, I'm calling this this particular one RQP. That is the position vector of what? Point Q with respect to what? P, because I am starting from P. So I am going to call that one RQP. Please, I hope students are following this. RQP. That is the position vector of point Q to point P. So, and that one is having a magnitude of that. You understand that? And the direction, like I told you, any position vector you want to show must always have its what? Any vector must always have the direction towards the direction of what? Positive x-axis. I hope students are following that. That is very, very important. So, and this particular vector I've taken from P, we're going to, you can see my x-axis is here, as you can see the arrow. Now, I'm trying to take the position of vector of RQP, which is moving from P to Q, and P is the reference point. So, at this point here, we can say the angle towards the x-axis, which is the direction of that vector, is written as angle. I can pick another. I've used alpha, I've used theta. Maybe I should take what? Gamma. So now, as you can see, representing vector with respect to a reference point is called position vector. And that is what you need to understand on that point, because the knowledge of this position vector, we are still going to be using it as we move forward in this chapter under unit vector. So I will stop here. And before I go, remember what I have said, that when you represent pictorial representation of vector, a very quick one before I leave, always keep it in mind. You are always going to what? You can join them, you can also separate them. Vectors are in two. It has magnitude, as you can see. Let's say this is a vector A, having a magnitude of A. Excuse me. We have very good. This is better. So it's having magnitude A. I just want our students to understand this concept. And it's having a direction. So the position of direction of a vector is always the angle it's making towards the x-axis. And as you can see, I'm trying to bring that out here in my diagram. So this is what we are talking about. Very good. I hope students are following. This is the direction theta. So now, if we want to combine this vector together, we must keep it at the back of our mind that this is the magnitude of the vector, this is the direction. Now, combining these two together, we now have, you can see, my dear student, the magnitude is this straight line, and the direction is the angle it is making to the straight line. So what I'm trying to say, my dear students, maybe I should just draw directly. You can see this is the magnitude, and we are talking about the direction. The direction, this is the magnitude A. The direction is going up, and I'm going to bring that out like this. You can see magnitude A, then the direction, which is always towards, you can see, I can now extend this for you to see the angle I'm talking about. So that is what we are talking about. So that is the first vector having A. This is the second vector having both what? Magnitude and direction. I call that one vector B. So I am combining two vectors together, and I want you to see it. Or to better understand this, maybe I should use a good diagram to understand this thing. let us have a good diagram. I still have 2 minutes more before I finish this slide. Very good. Now, look at this good diagram to understand the concept. Now, this is the first vector. The first vector is having magnitude of A, as you can see here. Whereas the second vector is having both magnitude and direction. You can see. Now here, I'm going to start from here and I'm going to move up. So that is what we are talking about. And I'm going to show the direction of that vector in this format. Meet me to use marker now. So as you can see from here, this is the angle now of the second vector, which is theta. So it is always towards the positive x-axis. That is the point I want to bring up. Then you can now combine the first vector with magnitude of A and the second vector with a magnitude of B and direction of theta. You combine them together, and when you combine them together, you have something like this. And you're from your geometry class. I know you guys are very, very good in understanding that. If this is what theta, this should be what 180 minus theta, which is the sum of angle on a straight line. And that will bring us to the next chapter where we'll talk more about the understanding of this concept. So guys, we can now say if the third vector is now vector C, we now say vector C here is now the addition of the first vector, vector A, plus what? The second vector, vector B. So always put that at the back of your mind that when two vectors are combined together, the third vector that are not acting in the same direction of the first two vectors is always going to be the addition of the first two vectors. So I will stop here. Another way you can write this, you can keep it in mind, is that the third vector here is the same thing. You can also bring out the angle of this third vector if you want to know about it. This one is always towards the positive x-axis. Remember that. So we can say the angle of this one, of this particular one, is tau phi. So another person can write it mathematical form by saying C vector is the same thing as C of magnitude and direction of tau phi. All these are going to be discussed extensively in the next class. So guys, make sure you follow this channel and subscribe to us to see more of us updates from us. Thank you guys and see you soon. Bye.